Hi, I'm Greg Kocher, presenting the paper Nested CTR-PTR Modeling for Sparse Purchase Prediction and Sponsored Search, which was some work done at eBay. In cost per acquisition sponsored search, we need an accurate and well-calibrated estimate of the probability of sale of each candidate ad impression. But there are a few challenges. First, data sparsity. Only a tiny fraction of impressions actually end in a sale. Meanwhile, click labels are less sparse, but they're a weaker signal. These probabilities may be around 10 to the minus 2, 10 to the minus 3, or smaller. Another challenge is sample selection bias. The classical factorization here splits PTR into a product of CTR times post-click CVR, but the CVR term is trained only on clicked impressions, but at serving time, it needs to score every impression, so there's an inference time mismatch. There's a lot of prior work addressing the issues I just mentioned, including a whole line of work on entire space multitask models. For example, ESMM models clicks, conversions, and their product jointly over the full impression space, and several other works extend these ideas and address various issues. These are all powerful, but they're a bit more complex and architecture specific, using custom heads, hybrid losses, or per task weights. So it would be nice if you could get a lot of the same benefit, but without the extra complexity and in a model agnostic way, which could be helpful when you have different stages of ranking that use different model families with different latency trade-offs, or if you already have dedicated teams working on click prediction versus sale prediction. So it turns out that a small probability approximation can help motivate a simple way to do this. Starting with the classical factorization that PTR equals CTR times CVR, we can take logs of both sides, and then for small probabilities, the logit of P is approximately log of P, since the log of 1 minus P is close to 0. So the figures here on the right in the table show that the approximation error is really small for small probabilities like you would have for typical CTR or PTR rates. So this all means that in the rare event regime, the multiplicative factorization becomes additive in logit space. So the sale logit is approximately a CTR prior plus some learned residual. That approximation from the last slide can motivate this whole simple design. So we can have an upstream CTR model trained on the entire impression space, and it can produce a logit score, and then we can inject that score into a downstream sale model. And we can do that in a few ways. So as a prior in the red path, we can add it directly to the output logit, or we can do it as a feature through the blue path and feed it as an input, or as both a prior and a feature together. And there are a few things to note here also. So it's model agnostic, so you can do this with anything that outputs a logit, like logistic regression or gradient boosted decision trees or neural nets. And also, both the CTR model and the overall PTR model see the full space of impressions. The first variant uses the CTR score as a prior, so as a fixed logit space offset, and the sale model learns a residual correction on top. This has a nice factorization-like interpretation where the CTR gives the initial estimate, and the learned correction acts like a post-click conversion model. And also, since the CTR and PTR can be computed in parallel and added, depending on the infrastructure, it might not add much latency. In the second variant, the CTR score is passed in as an input feature. So instead of just an additive offset, the overall model can learn richer, nonlinear interactions between click propensity and the other features, which matters because not all clicks mean the same thing. So the model can distinguish genuine high intent clicks from exploratory clicks, where some eye-catching item gets clicked a lot, but it's not purchased. And it also sidesteps the potential independence priority problem that ESMM has because the sale model conditions on the click signal directly instead of multiplying together independently estimated CTR and CVR terms. And the third variant just uses both CTR prior and feature. The nested CTR-PTR approach has some nice properties. First, we do entire space training for both models, which avoids the clicked-only selection bias. It's model agnostic and modular, and there's no hybrid loss that needs to be tuned to find good per task weights. It enables nonlinear click sale interactions instead of just a rigid multiplication. And since the overall model can be fit directly on the purchase label, it stays well calibrated for the sale prediction task. Here's the offline performance with everything relative to the previous single task production baseline. The nested CTR-PTR variants are in the shaded rows, and they show modest but consistent improvements across classifier and calibration metrics. The gains hold against a larger equal parameter baseline, so the benefit isn't just from the extra model capacity of having both a PTR and CTR model combined. It also beats the multiplicative baseline and a multitask model that optimized a hybrid loss. Overall, this isn't too surprising since we have the additional click signal, which the baseline didn't, but this shows that it's a simple and effective way to include the click signal and still be well calibrated. We did several rounds of A/B tests, and here we see that the prior plus feature variant showed stat sig gains in user metrics related to purchase rates and platform metrics related to sales volume with directionally positive ad revenue. Other variants also showed positive results, but they had bundled other model improvements at the same time, so we don't include them here since they're not pure ablations. The nested model also has intuitive feature usage patterns. When using CTR as a feature, other than the CTR score itself, the most important features become the post-click conversion features. So conceptually, the overall model behaves like a combination of a CTR model and a post-click conversion model. Also, if we look at the accumulated local effects plot for the CTR as a feature within the PTR model, we see that the effect of the CTR score rises nearly monotonically, but then it plateaus and dips at high CTR, which is consistent with exploratory clicks where some of the interesting items might have really high CTR, but not as high PTR. But a caveat here that the confidence intervals are wider in this sparser high CTR region. So overall, it's suggestive, but it's not fully conclusive. So to summarize, we use a simple approximation that turns the traditional CTR times CVR into an additive logit space decomposition. And we inject that click signal into the downstream PTR model as a prior, a feature, or both. And overall, it's a really simple but effective way to get a lot of the benefits of multitask engagement signals into PTR modeling, but without some of the downsides. And it brought offline and online gains and was deployed to production.